In this video, let's take a look at this LeetCode question. The question number is 19. Remove nth node from the end of the list. Okay, so for the level of this question is medium, and this question is related to a linked list. So you must have a knowledge of a linked list to be able to solve this question. Given the head of the linked list, remove the nth node from the end of the list and return its head. Okay, so in the example number one, you can see that we have given a linked list here. Okay, head of the linked list. Okay, so the linked list has the how many nodes? Five nodes. First node has the value one, second node has two, third node has three, fourth node has four, and the fifth node has five. And what we have to do is simply n is given equals to 2. So what does it mean? It means we have to remove the second node from the end of the list. We can see that the last node is this, and the second last is this fourth. So n is equals to 2. So what we have to do is simply remove the second last element, means second last node from this linked list. Okay, so after removing this, we can see our linked list should look like this, which have only four nodes containing value 1, 2, 3, and 5. The 4 is gone from here. Okay, so this is what we have to do is simply we have to remove the nth node from the end of the linked list. Okay, so in the example number 2, you can see we have only one node in the linked list and the n is 1. It means we have to remove the one node or maybe first node from the last of the linked list. So we have only one node inside the linked list. The last and the first, both the element is going to be this one. So we will just remove that node. So after removing that node, we will just have only one value which is null. So output is having null, means nothing. Okay, in the example number two, example number three. Okay, we can see that we have a linked list which have two nodes. First has value one and second has value two, and the n is one. What does it mean? We have to remove the first element from the last of the linked list. And at the last of the linked list, we have two here. So we have to remove this two. Okay, so after removing this second node, we will just have one node in the linked list, which is one. And we have to return the head of that linked list. Now let's take a look at the constraints. The constraints are the number of the nodes in the linked list is SZ. Okay, and the SZ is going to be 1 to 30. Okay, and the node values is also going to be from 0 to 100, and can be also from 1 to z as z. Okay, this is the question. So here is the definition of the linked list we have given here. So here we have a class, public class, name a list node, which is our definition for our linked list. Okay, so it contains one value which is going to store our value, and a pointer or variable, you can say, type of linked list node, which is going to store the next node's address. Okay, and we have here three definitions for our constructor function. One has nothing as a parameter. Second has a integer value as a parameter, and third one is having integer value and the list node's next address. Okay, so these are the three constructor functions defined for the list node. Now let's take a look at the solution. So we have here solution class. Here is the remove nth node from the end method, which is going to return a head of the list node. Okay, which is going to be a type of list node, and we are given a head of the linked list and one integer value. So what I'm doing here is creating one temporary variable type of list node. Okay, and I'm pointing that temporary variable to the head of the linked list. Okay, why I'm doing this is because I'm wanted to find the size of the linked list. So I've just created the variable integer type of integer size and initialize it with 0. And I have run the while loop here while temporary is not equal to null. So I will just plus size plus plus. I will just increase the size with 1, and I also advance the my temporary variable to the next of the node. Okay, so while temporary is not null, it will just uh, run the while. Okay, and if the size is equals to 1 after running this loop, if the size is 1, it means we have only one node inside our linked list. Okay, or size is equals to n. So what we'll do in this both of these cases, we will just return head dot next. In case of size is 1, head dot next is going to be null. And in case of size is equals to n, okay, means size is also n, and we also have to remove the nth node from the end. So in both of these cases, the node is we are removing is first node. So we will just return the head dot next. Okay, and we are again assigning temporary variable with our head of the linked list. Okay, why I am assigning it? Because so that I can use that variable again. Okay, so I am again traversing the loop, I mean linked list. Okay, so I have just applied here a for loop. So int I is equals to 0 and I less than size minus n minus 2. Why is it so? So it will just point at the previous node of the node which we have to remove. Okay, so what it means, let's take an example. Let's take this example number 1. In this case, so the size is going to be what? Let me create a variable here. Size is going to be 5 in the example number 1. If we take example number 1, okay, and or n is equals to what? 2. Okay, so what I'm doing here is I'm running this loop until size minus n minus 1. Okay, so size is 5. 5 minus 2. 5 minus 2 is 3. And 3 minus 1 is going to be what? 2. Okay, so this loop will run while I is equals to 0, I is equals to 1. So it means this loop will run 2 times only. Okay, so what it does, the temporary pointer is pointing at the first head node of the linked list. Okay, so suppose the temporary pointer is pointing here, so this loop will run for the I equals to 0's value, and I'm just advancing the temporary variable to the next node. Okay, so for I equals to 0, temp is equals to temp dot next. So temporary variable just now point here. Okay, and now I will increase, and for I equals to 1, this loop is also going to be running because the condition is 2. Okay, so temporary variable move again to the next node here, and the next node we are the just previous node which we have to remove. Okay, means we have to remove the fourth node and we are the on the third node. Okay, so what we can do is simply change the, now the loop will be break. Why? Because this is 2 and the I is also going to be 2. So 2 less than 2, it is not true. The loop will break. Okay, so what we will do here, our temporary pointer is pointing to the third node. Now we will just change this connection which is pointing to the 4. We will just change this connection to the 5. Okay, so no pointer is pointing to the 4. 4 will be just collected by the garbage collector. Okay, so we are changing this connection which is pointing to the this fourth node. We will just change this to the 5. Okay, so temp dot next now will point the temp dot next, which is this fifth node. Okay, so the fourth node is skipped from here. Okay, and it is permanently removed. Now we will just return the head of our linked list. So this is how what is the solution look like. Now if I just run the test cases, let me run it. Okay, so all the sample cases are running. Now let me submit it. Okay, so you can see that solution is accepted successfully. Okay, so this is all for this question. Now, if we talk about time and space complexity of this code, So the time complexity is going to be what? Big O of n. Why big O of n? Because we are traversing through the linked list. Okay. And the space complexity, let's discuss about it. Space complexity is going to be what? So we are not using enough space here. Okay, we are just assigning the one variable which is temporary and one for size. Okay, so this is the constant memory allocation. So the space complexity is going to be constant and the time complexity is linked. Okay, so this is the algorithm for solving this question.